Here's a physics question about mixing liquids. And you'll see in this question that the masses of the liquids are the same. It says equal masses. So when the masses are equal, you can use this equilibrium temperature ratio. The equilibrium temperature when you mix, I'm looking at this, I'll put it in red here. I'm looking at this. The equilibrium temperature when you mix two liquids is the temperature of the first liquid times the heat constant of the first liquid plus the temperature of the second liquid times the heat constant of the second divided by the heat constant of the first plus the heat constant of the second. So I'm going to check this for, and I've written down all the temperatures here. The temperature of liquid 1 is 14, temperature of liquid 2 is 21, temperature of liquid 3 is 29. And then when I mix them, the equilibrium temperature is for 1, 2 when I mix them is 16, and for 2, 3 is 24. Oh, 24.3. Uh-oh, I also almost lost a digit there. That would have been terrible. Okay, let me get enough space here. Sometimes I have trouble manipulating this page to get the right space. Oh my goodness. There we go. Okay, I just want to get a little bit more space. All right, so I'm going to do the situation for 1 and 2. The equilibrium temperature, I'll just write 1, 2. The equilibrium temperature for when liquid 1 and 2 are mixed is 16 equals the temperature of 1 is 14. I don't know what the heat constant is, C1, plus the temperature of the second one is 21 times the heat constant of the second one divided by C1 plus C2. I will multiply both sides by C1 plus C2 to get it out of that denominator. In other words, distribute the 16. 16 C1 plus 16 C2 equals 14 C1 plus 21 C2. And now I will subtract 14 C1 from both sides. 16 C1 minus 14 C1 is 2 C1. And I will subtract 16 C2 from both sides equals 21 C2 minus 16 C2 is 5 C2. Now, the mixture I'm looking for is 1, 3. I'm going to write this over here. So one of these constants, either the constant for 1 or constant for 3, I'm going to set to a simple number. I'm just going to say, imagine it's 1. So I'm going to say C1 equals 1. Very simple to use. So I can do 2 times 1, that's what C1 is, equals 5 times C2. So 2/5, I divide both sides by 5, equals C2 equals 0.4. So I have C1 already. I'm going to use that in my final calculation, and it's going to be a very simple formula because what I'm doing now by getting them in ratios. And so C2 equals 4. I'm going to use this to find C3. So now I'm going to do the situation for T for 2,3. T23 is 24.3, the equilibrium temperature, equals the temperature of the first, which is liquid 2, is 21, times, I don't know what the constant is, C2. I mean, I have it here, and I'll substitute that in a second, but for now I'm just putting C2 plus 29, the temperature of the third one, C3, I don't know what that is, divided by C2 plus C3. I'm going to put this 0.4 in a little bit later after I manipulate this. So I'm going to multiply both sides by C2 plus C3. In other words, distribute the 24.3. 24.3 C2 plus 24.3 C3 equals 21 C2 plus 29 C2. I was just thinking, could I, if I had 0.4 plus that, I'm trying to think if I could, well, I think if I plugged in that 0.4 too early, it would just complicate things. So I'm going to plug it in at the end here. So now 24.3 C2 minus 21 C2 is 3.3 C2. Those are gone. 29 C2, this is supposed to be C3. 29 C3 minus 24.3 C3 equals 4.7 C3. When I put this into Google Gemini, it thought, and ChatGPT, it thought it was 3.7. No, 4.3 it kept coming up with, but it's 4.7. Remember, those AIs don't do math. They're language models. They do language patterns. So now I have a value for C2 is 0.4. I can plug that in now. 3.3 times 0.4 equals 4.7 C3. And then I can divide both sides by 4.7. 3.3 times 0.4 divided by 4.7 equals C3. And then I can go to Desmos, the beautiful Desmos, and what is it? 3.3 times 0.4 divided by 4.7 is 0.2808511. I'm going to give enough digits. 0.2808511. I think that's enough digits. And so now I've got C3. So now I've got C1 and C3 for when I mix liquid 1 and 3. So I've got that. All right, what is the temperature for 1, 3? Don't know. Equals the temperature for 1, which was 14, times C1, which I said set to 1, plus the temperature for C3, or the temperature for liquid 3, which is 29, times C3, which is 0.2808. 0.8511. If I ever say 0.2808, I'm trying to get in the habit of saying 0, because people say, actually, it's not a 0. It is a number, not a letter. Or it's not an O, it's a number, not a letter. It's 0. So I'm trying to get in the habit of saying 0.2808511 divided by, well, C1, which is 1, plus C3, which is 0.2808511. So it's 1.2808511. That's the temperature, equilibrium temperature, when 1 and 3 are mixed. And I think I've already done that calculation. I certainly have. Approximately 17.29 degrees Celsius. So that's the final answer. And I think it said it wants it in degrees Celsius. So there it is, about 17.29. If you need to watch this again, I'm not going to repeat it. Be kind, rewind, watch it again. You can watch it in slow motion. I'll sound more like this. Or if you've got it, but you just want to make sure you've got it, play it in fast motion, and then the whole problem will solve like, here's 009, 17.29 Celsius. So you can do the whole thing real fast. But anyway, you can watch this again and make sure you understand it. And then once you think you understand it, erase everything, just look at the question and work it all to make sure you can get this question right and get that 17.29 number. But there's the method to do it.